July Lowry Landfill CAG meeting. By now you all are pretty familiar with the virtual meeting, so I'll be really quick, just a couple ground rules. Please introduce yourself. If you want to speak, you can also go to the chat box below at the, let's see, it's at the bottom of the screen, and convey something that you don't want to get lost if the speaker is in the middle of speaking. So Janine can either announce it or invite you to make your comment once the timing is right. Also, typically we do like you to hold comments and questions until the end of the presentation so we can try to manage the time. And let's see, you can also text Janine if you're having any difficulties, technical difficulties or otherwise, at 303-921-2208. And I think that's it. Oh, be sure to mute your computer. Bottom left, there's a microphone icon you can click on. If you're on just the telephone, you can hit *6 to mute and *6 to unmute. So with that, I will, Janine, did you want to add anything else?
I would just say that please mute yourself unless you're speaking, because right, the echoes and things can be really atrocious. If you're on a computer and a phone, make sure that one of them is muted throughout the meeting. If you have some computers don't have mics, and that's just fine, but when you have a computer mic and you have a phone, that can really cause a wind tunnel in here. So just make sure one of them is muted. That's all I've got.
Okay, so with that, I will pass it over to Linda Kiefer, the EPA project manager, to go over some site updates.
So thank you everyone for attending. I hope you're enjoying your summer. And welcome anyone who has not attended previously. So I'm going to go through some of the site updates and start by sharing my screen. So the CAG had submitted some questions ahead of time. So through this conversation, I'll try to address those questions that were requested, and then we can have questions at the end. And some of you have seen this diagram before that I have provided. It outlines projects that were developed from the last 5-year review. The last 5-year review occurred in September of 2017. These projects that arose from them were originally scheduled to be completed within a year of that 5-year review. So that would have been September 2018. So as you can tell, we're making progress, but not very quickly. So on here, the green ones have been completed, except one is just 95% completed. So the synoptic sampling occurred, the cessation summary report was completed. The North End investigation report, which there was a public review comment process, is all completed except for Appendix F, which is the risk assessment portion of that. CDPHE and EPA are collaborating and working together to get that finalized. Another project that was finished was this numerical model calibration report. That model will be used to look at the north boundary barrier wall, MW 38, so different areas within the site. So that was completed, and our 3D visualization report was completed. So all those, except for the North End report, are being put into our electronic records and will be available on our website, and we'll let you know when those are available. CDPHE has put some of them in their records already. Then 2 of the projects that are in the draft category are the containment system evaluation. And that is a supplement to the containment zone analysis. It incorporates the numerical model and some other techniques. So that plan is being drafted and reviewed by the state and the WSDs and EPA. And the conceptual site model was drafted in collaboration between EPA and the WSDs. And that will be going to the state for their review shortly. And then that will go for a public review process. So the CAG will have an opportunity to review and comment on that before it goes final. And then our final project is updating the groundwater monitoring plan. So that's all contingent on these other things being completed. So one of the questions was about TAG grant funding. EPA has agreed to give the TAG grant an additional $25,000 in addition to the $50,000 that they've already received, and then have that grant continue for another year. Bonnie has put in an application for that. So one of the questions was, why just a year? And we're hoping to have all these projects completed in the next 6 to 9 months. So once that happens, the site will go back to its operations and maintenance, normal routine things that they do to maintain the site. The site status reports will still come out. And then in 2022, we'll have another 5-year review. Let's see. And then another question that the CAG had was about the facilitator. We have sent all of everything that was needed to EPA headquarters, and it was forwarded on to our Cincinnati office. We don't know exactly when that process will be complete and when the facilitator will be hired, but we hoped by September that we'll have someone on board. Another question was when is the community involvement plan going to be available? That will be available next week. And Lisa and Janine will be reaching out to the CAG members to set up a discussion of how their comments were included in that final plan. We also had a question about why the Gun Club Estates wells are not sampled as part of the Lowry landfill site. And so EPA regulates the Lowry landfill site under our remedial program, which I'm part of, the Superfund program. Our recent investigations don't support that the plume poses any risk to the private wells and Gun Club Estates, so we referred that citizen request onto EPA's site assessment program. EPA, through a grant, works with the state site assessment program, so they're conducting an evaluation to determine whether sampling is warranted. And some of this evaluation has been delayed due to COVID restrictions. However, when that evaluation is complete, the property owners who requested that their wells be sampled will be contacted. EPA doesn't regulate domestic wells in general, so we do encourage well owners to monitor the quality of their water that they are supplying to their households. That's just regular maintenance for private wells. So I know I covered a lot in that. So do I have any questions, or are there any questions?
This is Earl. I have a question. In the near term, is there a model, groundwater flow model? I guess not within the next 2.5 years, because it doesn't sound like it, but we have a calibration report.
So Sarah, are you in the line?
Yes, I am. Yeah.
Can you answer that? Because I assume it's The containment system evaluation is probably what Earl's talking about, but can you?
So the groundwater numerical model was developed to support the containment system evaluation, and that's what that calibration report's associated with. That work, so there's the containment system evaluation planning document, which is essentially saying how these different areas of study and investigation are going to be pulled together to evaluate the efficacy of the containment system as it relates to groundwater flow in the area and potential for contaminant migration. That's a big piece. Right now we're reviewing the plan. So the plan being how this is all going to be stitched together. Once we agree on that, the implementation of the plan will involve the use of the groundwater model. And to get to that next step, there will be coordination between the agency and WSD technical experts, consultants as well, on how that particle, the particle flow in the numerical model will be implemented. So where we're what areas of the subsurface we're interested in the particle movement and evaluating based on. I don't know if you just heard my son, but yeah, he's 5.
So we're waiting for this containment system evaluation work plan to define the operation of the model in the future.
Right, exactly.
Okay.
I have a question. And I don't know if my question pertains to anything that Earl just said, but Linda, you mentioned that at some point you're going to go, or I guess after these final projects are finished, then the site will go back to a normal routine of operations and maintenance. And what I want to ask about that is the normal routine to continue to allow the contaminated plume to continue flowing? Is that going to be considered normal and routine?
I think that's why we're doing the containment system evaluation to see what's happening. That's why we did the 3DVA. So there are contingency measures in the record of decision to manage the contamination. So those will be looked at. So it's to be determined. I mean, there's not a answer one way or the other. Yes, everything will be looked at. If measures need to be put in place, they will be put in place. And the goal is to go back to routine operations and maintenance, which is continuing now. I mean, they're operating and maintaining the site. But the goal is to complete these and put in contingency measures if needed, yes.
Okay, and I guess what I'm concerned about is that after all these years, it would appear to me as though allowing the contamination to continue flowing off-site and through the neighborhoods has now over the years become normal and routine. That's what I'm concerned about.
So, I mean, we'll look at everything and anyways, something just happened on my screen. We will look at everything, and if there's measures that need to go into place, they will. I mean, okay. Do we have any other questions?
Okay.
This is Earl again. I'm still learning my place with all these topics, and if there's a better place in the agenda for this question, then I'm happy to defer to that. But I was looking at the visualization products, and I'm looking for the geology. Is there any visualization of the geology that comes along with the borehole logging? I mean, I can see the top and the bottom of the wells, marked with blue balls, but in between, I guess there's no information. Is that-
Earl, this is Diane. As part of the zip files that we discussed this afternoon, I don't remember the number of it, but there was one file, I think maybe number 6 out of the 12, that included the relative K, which was how we visualized the weathered geology. And then the unweathered geology, we visualized using indicator kriging of the, oh, I'm blanking on the name, Sarah, help me out. It was the soil type, the hydrogeology. So they're visualized 2 separate ways, but they are in the 12 4DIM files that we talked about this afternoon. So if you have any questions, just give me a call and I can show you which ones we're talking about and why we visualize them differently. Those were topics that were discussed before you became on the project. So, you know, they could totally be confusing when you just see it, you know, without the context.
Okay, I'll go back and do some more homework.
Yeah, and
Thanks.
give me a call. I'd be happy to
Okay.
go through them with you too.
Okay, thanks.
I think you were just referring to the soil classifications, like the standard soil classifications.
Yeah, there was a fancy word that I was missing that I just couldn't get my head around, but it'll come to me as soon as I mute and everybody moves on. But
Okay, do we have any more questions on that? Okay, let's move forward then to the Molly update from Steve Richtel with the WSDs. And Steve, I think you have something to share.
I do. Can you hear me? I just unmuted.
Yes.
Okay. I just want to recap a little bit just so we're all on the same page before going into the material, if that's okay. In November 2019, so late last year, we had an exceedance of our treated water discharge limit for molybdenum. The limit at the plant in our discharge permit is 430 micrograms per liter. The plant was immediately shut down. We notified Metro Wastewater and began to sample all the different influence streams to the water treatment plant. Let me show you a table. Come on, open up. There we go. And share my screen. Where'd it go? Technical difficulty, sorry. Share screen. Are you guys seeing this table?
Yep.
Okay, there's a lot of information here. I'm going to do it in a pretty high elevation here. So these are all the influence to the water treatment plant. They're all, and as you see, some of them are extraction wells. We have the north boundary barrier wall, the north toe, the 38 sand channel, etc. The date they were sampled in November, and here are the concentrations that we got for those samples. So as you could see, with a level 430, the concentrations are really only here in this one area, on this one well, monitoring well 113. It's an extraction well that we use as a rod contingency measure to extract dioxane to try to bring the compliance wells into compliance. So at that point, we ruled out that it was coming from the landfill, that it was coming from the north end plume, that it was coming from any other place other than this one small area. Now, what that looks like is, stop sharing. Hold on one second.
Okay, that's all good. I was having so much trouble with my system. And I'm just watching Steve now.
Hold on. Where the heck is it?
And he's having trouble. So,
Janine, can you mute
it is. I mean, Steve's
Bonnie?
having trouble.
Oh, she is muted.
Okay, so, okay, that's okay. What about what about the CIP? You should give me an answer on that. Okay, 3D
I think
visualization.
it might be Richards that it's coming through.
Okay,
So where this well occurs
I'll just
is
thanks.
right in this little spot right here, just north of the north boundary barrier wall. And as you can see, there's a number of wells around there that we have sampled. I'm going to expand this and try to move it over. And what I'm going to put up next, but I want you to see, because we have now collected 115 samples from 72 wells around the site. And this is showing you the concentrations. We'll focus in on this area right next. But as you can see, and we've gone all the way to the south end of the site. And the only place this moly occurs is in one small area. Now it's going to make me stop sharing again when I go pull up the other figure, I think. Does that show up?
Yes.
Good. And now I'm going to blow this up a little bit. So MW113 extraction well 1 right here occurs right in this little spot. And we've sampled wells all the way around it and beneath it. And this is the only area where it occurs. But that extraction well doesn't have the highest concentration we found when sampling around. This one here, which is 10 feet from it, 42,000 micrograms per liter. So we were able to define the lateral and vertical extent of it. I'm sorry, I missed a step. After getting those initial samples from the water treatment plant, we were able to calculate how much water we could pump out of this area and still be in compliance with our permit, work with Metro, and they approved us reducing the extraction from where we were down to 1 gallon per minute. And that was fine for a time. Concentrations at our extraction well continued to increase. It was 6,000 at the beginning. Now they're hovering around 16 to 18,000. And we have reduced the extraction from that well again to 0.5 gallon a minute. So it brings up the question, where the heck is this moly from? Is it from the landfill or the waste pits? Well, on that other map that I showed you, there are many wells very close to those sources that don't have moly on. So we feel like that's not the probable source. We know that sewage sludge was disposed of in this area, was land farmed in this area. So is that a potential? But we found that and we actually had some of the sludge from the site sampled, and it had very low molybdenum in it. So we ruled out sewage sludge. Could it be possible that in the drilling of the wells themselves, there was some sort of lubricant, fluid, or downhole equipment that had moly with it? And the answer to that question is no, so that was ruled out. So then we asked ourselves the question, is it naturally caused? And what we know is that the front range of the Rocky Mountains, just up I-70, is a very molybdenum-rich area. In fact, the nation's largest molybdenum mine is just outside the town of Empire. So it's possible that as those mountains were eroded, that during high energy flood cycles, if you want to call them that sediments were carried down into the Front Range area, became part of the Dawson or the Dawson Arcos over the course of, this is 30 to 40 million years ago, and laid sediments down that contain high molybdenum. So we retained all the core from when all these wells were drilled. We had our geologists go back to the core to look for what he would consider to be minerals that might contain molybdenum in it. In particular, he was interested in pyrite. And from that well, MW113, EW1, he found 2 intervals that would have been saturated that looked like they contained pyrite. So we sent them off to the lab to be looked at, and it turns out the shallower of those 2 did not have pyrite in it. And the bottom one also had low pyrite, but it had high molybdenum with 68,000 milligrams per kilogram, which theoretically could produce the concentrations that we're seeing. So we wanted to do a little bit more investigation of that and used a more advanced technique, and the handout that you all got goes into what the names of all these test methods that we used were. And we didn't find a very good correlation. So we pulled the core from a lot of the wells that are around there and looked at them with a field instrument, took 407 measurements, and it turns out that there is a pretty good correlation between the geologic material and the high molybdenum. We are finding that when these were deposited in high energy environments, that these well-graded sands with a little bit of clay or clay and silt and what are called clay clasts correlate very well to where the high moly is. The source of that material, well, we do know that the Pikes Peak granite has high molybdenum, and we know that the Castle Rock conglomerate, the Castle Rock formation where it has rhyolite, also has high molybdenum. So it's possible that it was carried there in high energy environments 40 million years ago. It's all very interesting. So we believe that it is naturally occurring, but the real question is, what are you going to do about it? Well, we are going to continue to pump to meet the ROD contingency remediation requirement for dioxane. We're going to try to maintain a cone of depression in the area to minimize the potential for migration. And we are in the process of designing, procuring, and installing a treatment system that will be added to the water treatment plant so that we can use it if needed. And the technology for the treatment that we're going to use is called ion exchange. And we will continue to sample the wells in the area to monitor for changes over time. Any questions?
Earl, Dixon, Steve, I have a question.
Sure.
What geochemical mechanism do you think is causing the molybdenum to be released into the groundwater in dissolved form?
You're over my head. Sorry, I don't know how to answer that question.
Well, under normal conditions, the molybdenum would just be sitting there, wouldn't it?
Yes, we believe that ceasing injection of water, this groundwater could have been sitting static for eons. But when we ceased injecting water, the whole hydrodynamic system, downgrading of the north boundary barrier wall, is changing. It continues to change. And we're dropping the water levels in that area dramatically. So this water may have never been extracted before, and we're just now getting to it. It may have been sitting there for eons.
Well, there's ways you can determine the age of that water.
Yes.
So
Agreed.
you're going to end up with isotopes and geochemistry at some point in this, because you've explained the source, but not the mechanism. Is that true?
True.
I guess there's, I don't know if there's any data or information or study on redox front associated with Lowry landfill.
I would add that a lot of this is in a technical memorandum that we have just today delivered to EPA. And a lot of it is controlled by EH and pH. And now you've depleted my entire knowledge of the geochemical.
Well, you got to start somewhere, Steve. I started at 0 myself. But we'll Okay, we'll just have to hold that one and wait for the memorandum. Thank you.
And I do think we reviewed the data for any sort of obvious changes in, you know, water chemistry like EH and pH and didn't see anything. So
From the literature I've been reading, Cyril Dixon again, there's a lot of complicated geochemical measurements that can be made. I don't know if it's appropriate for this type of problem, but I mean, it's very unusual to find molybdenum concentrations that high in a natural setting like we have here. I mean, I can go with the depositional environment, how the stuff got there and where it came from. And if it's tied up in clays, that's all valid, but something has got to be attacking those clays and causing them to release. And that's some interesting chemistry there, because clays don't usually like to let go of things very often. That's all.
and one thing that'll be interesting, you know, as Steve mentioned, monitoring changes with time, that static sort of water now being accessible due to the lack of input from potable water injection, that could be interesting to see. Was it a one-time sort of like flux out, or are those levels sustained? So that might provide some information going forward.
Yeah, I guess maybe we were injecting fresh water at this location, and so that was probably highly oxygenated. And so, did that have something to do with the chemistry of release? You know, 'cause like I say, I mean, it sounds like you've got the source figured out, and if it's tied up in the clays, then if it's old groundwater and they were released molybdenum long ago, or it's something more recent that caused the release. That's kind of some of my thinking.
Sarah, this is Tom. As being a non-hydrogeologist, what I'm saying may not make sense, but right now you're going through the process of trying to upgrade the treatment plant in order to treat a lot of dissolved molybdenum. And it seems to me if you could find the reason that that molybdenum is dissolved, I guess if it's been dissolved for 2 million years and so it's suddenly coming up, that can't be changed. But if it's dissolving because of some hydrochemical, geologic, and I don't know if that's the right term to use, but function, for instance, say the right redox and pH is coming from the landfill and getting into where the molybdenum is, that if you found that and were able to put an extraction well to in that source pathway, then the molybdenum would no longer be dissolved. You could pump out that pH and redox potential and treat that at a much cheaper cost. So I'm wondering, the bottom line of all that question is, are you actually looking to try to find out why that molybdenum is now dissolved, and once you found that, looking for a pathway and a source of whatever's dissolving that molybdenum, so that you get it on a much more economic, beneficial scale, solve the problem?
That's an excellent point, Tom. I should mention we're also looking at some different alternatives that would involve in situ treatment to stabilize that area.
Okay. Thank you.
I have a question. It's sort of a curiosity question. Based on what we know today, and if this information was known years ago, would you have done the water injection for all those years, or would you have done something a little different?
I'm not quite sure how to answer that question. It's speculating about, I have no idea.
Okay, are there any more questions for Steve?
I have a need for clarification. Am I to understand that this concentration of Molly is going to continue to be monitored, and that there's no way at this point that you're going to seek a mitigation of that chemical? You're just going to see what happens to it? Because I'm falling in the support category of what Tom said about maybe there is something that's coming in a pathway towards that and needs to be addressed instead of just monitoring the molybdenum. You know, I think that it's a serious concern.
With all due respect, we're not just monitoring it, we're extracting it.
Okay, but at a very low rate. Am I right about that? Because of the need.
But once we have more robust treatment available at the treatment plant and we can remove the moly, we can increase our extraction rates.
Okay, and I'm sorry, again, I'm not sure what the timeline is on that. Do you know?
Our hope is to have it fully operational by the end of the year.
End of this year. Okay.
Yes.
And that would mean that you could extract back to the 3 gallons per minute or whatever it was before. Okay. Thank you.
And in addition to that, like I said, we are also looking at ways that perhaps different things can be injected into the ground to demobilize the moly, to make it so that it's not dissolved.
So
for example, this is a 2-acre area. We could inject grout, cement, solidify that little zone.
Okay, that it seems to me like if we're talking millions of years, that a little bit of concrete isn't going to stop it. So I appreciate the efforts that are being made to control this. I'm just going to be really curious as to what actually happens. So I think you're suggesting that concrete might be one commodity, but not injecting chemicals in there.
Correct. Well, there are other ways to do it. If it is truly controlled by EH and pH, then there are ways to other things that could be put in the ground that would cause those conditions to reverse.
Okay, and I'm somebody who doesn't know anything about this, so I'm just really curious. If the moly is moving, then is it moving north like the other chemicals are moving?
No, it's contained in what is, for lack of a better word, where it got deposited is like a little bowl.
Okay.
And we're extracting from the middle of the bowl. So the water levels on the outside of the bowl are higher than where we're extracting. So everything is moving towards our extraction well.
Okay. Thank you. I appreciate that. Helps me understand it.
Steve, there's one other question. This is Tom again. I know you pointed out before to us that within the site, well, C702Q2 in 1995 had 45.8 micrograms per liter of molybdenum. Have you retested that well to see if that might be one of whether or not the molybdenum has gone up and may give you some information when you might be looking for a source of the pH and redox problem.
Like I said, we've sampled 72 wells, and I would have to look at the database to see if that was one of them. And we're continuing to do others.
Right, but I mean, it seems like going back to a well that in 1995 had molybdenum when nobody else did, and retesting it might be something to consider. Is that an unlikely scenario?
No, it's not an unlikely scenario. What was the name of it? C702? What did you call it? I mean, there's 500 wells out here, Tom. I don't have a perfect memory of every one of them.
On your blow up, and it's C-7, and it may be a 0 or a Q. No, it's C-702 Q2.
Okay, take a look at it.
Thank you.
Question?
Okay, any more questions? All right, let's move on to Dietrich McGinnis. He will be providing a brief summary of the surface and groundwater technical calls that we had over the last month and a half or so.
Thank you. I'll go ahead and do a screen share. And oh, that didn't work, did it?
Yes, it did.
Oh, so we have
Surface water monitoring.
yeah,
Yeah, it's up there.
cool. It's kind of weird. It doesn't show it on mine, and it's not showing. So, but I'll go with it. Well, anyway, just a quick correction. Today I'm going to present on the surface water discussions we've had on surface water monitoring, not the groundwater. Better fits the time allotted, and we're kind of working out how we're going to discuss that. To give you an idea of, did we get a change to another slide?
Yep.
Okay. This is the flow chart we put back together back in May when we decided to have these calls. And the top and the bottom are just some of the data input with the actions in the middle. We're about a month behind. But the idea was to have these discussions, collect this information, so that when it becomes time to review a conceptual site model as well as a groundwater modeling plan, we can all be looking at the same data and hopefully have kind of a common idea of what's going on. So today I'm just going to go over a little bit of background on the remedy for surface water in the site, the role of surface water in the current assessment needs, as well as what data is available. And there is a risk assessment. It's actually a risk screening, to be correct, for a risk screening for surface water. So OU5 is for surface water and sediment at the site, along with OU4 and the components of the remedy that were involved with that. Were more or less just to get the site covered, periodic monitoring of surface water runoff, and some wetlands issues, and operation and maintenance of surface removal water action, and the north boundary barrier wall. So that was the overview way back when of what was going to happen. And the surface water removal action, the SWRA, included a blanket drain system with a clay cap. And what it did is it isolated water coming to the site and got it off of the site without it getting contaminated. Was the whole idea. And it's from the 90s. It's a pretty common type of action. And it doesn't include areas north of the north boundary barrier wall. This was an action that was just at the site itself. And I think in our discussion for the rest of this presentation, that is one of the more important points. So And the other one is that the actions for surface water controls are all related to stormwater. And I'll have a slide in a second to talk about stormwater versus surface water and kind of where that divides out. And the surface water controls at the site predate the discovery of the release past the north end of the site, the 1,4 docks and plume extending north of the site. So the current plan, which is from 2008, is stormwater only, collecting samples at the north end of the site where everything's draining to and running them for a few parameters. It does direct collection of flow data, and if somebody on this call knows where that flow data is, I would love to see it. But the difference is stormwater versus what we call base flow, the groundwater recharge to Murphy Creek and other drainages or other creeks and tributaries. And base flow is not stormwater flow. It's usually groundwater, shallow groundwater coming into the creek and draining through those systems. And it is the most likely, with the site capped and stormwater controlled at the site, it's that base flow that is most likely to have issues as the shallow groundwater that we know is problematic out there is draining into the surface water. So the second 5-year review in 2007, and Sarah, thank you for sending that to me. That was a great document to look at for this. Directed the responsible parties to develop a long-term compliance monitoring program for surface water. And it highlights the finding of 1,4-dioxane as high as 79, 1,4-dioxane as high as 79 micrograms per liter in surface water. And this was in 2006 at a location, I think it's near Dad's, and we'll put a map in a couple of slides. The monitoring plan that was put together collects TSS, measures suspended solids, oil and grease, pH, and COD, does not include 1,4-dioxane, at one location, SWMP at the northern end of the site. So it doesn't really capture what may be being released from shallow groundwater further downstream than Murphy Creek. And another question I had that's still remaining after the phone calls was, is there any action levels associated with that? And if somebody wants to ask that question, point that out after the presentation, it'd be appreciated. So I don't know how well y'all guys can see the map. I believe you can see my cursor. So I'm just kind of go through the different sampling points. This is the one that had the highest value down here. The little red dots are the different surface water sampling points. I believe some of them are ponds. One up here is actually a pipe that comes in under a bridge. And then these are the farthest north. Now, one of the important things to note from this is that one of the next highest concentration, running about 10 micrograms per liter in the sampling that was used for the screening, came from right here. And it actually does have, it's one of the few locations that has a shallow well associated with it. So we're talking about shallow groundwater discharge in that area. Those can be very important to compare.
Dietrich, just to pause you, I don't know if it was just me, but if you were moving a cursor around, it didn't show up on my screen.
Oh, okay. Does that help? Okay. So just the important things from that history. The site has a history of releasing surface water, or releases via stormwater, pre-corrective actions, but a lot of those have been, the cap and stuff has addressed a lot of that. The stormwater releases have been the subject of actions, but there's no controls for releases to surface water via shallow groundwater past the north end of the site, past the north boundary barrier wall. And 1,4-dioxane has been detected in the north end of the study area and all the way to the north end. Those farthest points have had hits, relatively low, but they've had hits. And the highest one, much closer to the site, was around 79. And like we discussed, we do actually have, at least in one case, some wells near one of the sampling points, SWMC3. And you can see that when we look at dates where the well was sampled pretty close, or at least within a few months of the surface water, they do match up pretty well. However, this was base flow. I can look at the just weather records for those dates and pretty much figure it out. And there was some direction in that 5-year review to look at base flow. But when we look at storm flow events, and this one, the 16th, we do see a bit more of a difference. And this is probably because the capping and other things at the site are probably relatively successful to isolate precipitation hitting the site from getting contaminated. And we see a dilution happening with storm flows in the creek. Again, very small sample, very old data, but it's, at least we do have that for one event. It illustrates, I think, some important points about the connection between the surface water and shallow groundwater.
Hey, Dietrich?
Yeah.
This is Diane. You have those labeled as milligrams or per liter. Aren't those in micrograms per liter?
Yeah, those should be micrograms per liter. And let's, oh, all righty. Yeah, that should be micro. That may, sometimes symbols get converted. So if that happens again, I'll highlight it. Thank you for catching that. So, no, that one's micro, so we don't have to do that correction. So although there's not a plan, some opportunistic samples have been taken in the Murphy Creek drainage north of the site. The most recent samples for surface water sampling north of the site are from 7 sites, and unfortunately they're relatively old, 2016, 2007. The one area north of the site does have some more recent data, but it doesn't have really a full range of analysis. It's very, very limited. The only data in the database for Sand Creek effluent, which has been part of our discussion on possible sources, is from 2006, and it's at 1.7 and 1.8. So relatively low concentrations. And that's kind of up in the air how much of that was used out there or what the role there is. But in samples labeled J Pond and M Pond, which aren't real well mapped out, or SW Quincy, but we're going to assume those are surface water features from 2006, 1,4 dioxin was not found. And we would expect that if we're having sources with the irrigation water at the golf courses, to see some in those types of features. Shallow groundwater and the surface water north of the site has been found to be consistent or greater than shallow groundwater when their well data can be comparison. But again, tiny data, just a couple of data points. So one of the interesting features of this is we have a risk assessment associated with that, and we have a discussion of this coming up next. So I don't want to spend a whole lot of time in it, just to kind of highlight how this relates to the data that's available. And I'm sure we'll get into more about where this comes from, but risk between 10 to risk greater than 10 to -4 is a problem. Between 4 and 6 is usually part of management decisions, and a risk less than 10 to -6 is usually not a problem or pursued. So the plan we have is from about 2007, and Sarah, thanks for providing it. But it doesn't have a specific plan for collecting data. It's actually a couple paragraphs in another plan, which is the first one from the north end. And it only includes 7 samples, one of which is the mystery pipe, and only 1,4-dioxane and nitrate data were collected. So it's very specific to risk from 1,4-dioxane. And I think it kind of goes through nitrate a little bit, but not really much of the discussion. Not the other risk factors, not the other COCs for the site. It did not include flow data in the discussion of the data, which I think is really, really important here, because if we're looking at particularly this system moving past where areas we have wells, potentially recharging groundwater at other locations, that flow data is really important in interpreting the data. We also have a problem that in 2010, the risk valuation changed. And so the values that were used to calculate in this, in the current risk screening are not, they were revised down, which would have a significant effect on the interpretation of the data. So it's not based on and it's also not based on the full range of values or on an upper confidence interval. But one of the main problems here is it's just such a small data set that it's really hard to interpret, to say a lot more other than it's occurring. So I have a few reference there. That's the later, just the later references for 1,4-dioxane and the values that will be used in this type of screening. But the important part is, from this, is that RAOs include prevention of horizontal migration and dissolved groundwater contamination offsite and to surface water. So surface waters have been addressed and a part of the way the site was directed to be managed. The 2007 5-year review included work study defendants should develop a long-term compliance monitoring plan for surface water. And we don't really see anything that would represent the issue on the north of the site itself as far as surface water. There's not a sampling plan. There's not routine data collected. What data is available, none of it has flow data involved with it. So we don't know whether it is stormwater or whether it is base flow. And that's just an important thing to know. It's very difficult to interpret any of that data without knowing that. The current risk screening was not based on the available data, and there's still no plan to collect surface water data. And the current risk screening has been out of date for more than a decade. An update would show a significantly greater risk. Whether or not that would be above -4, it's kind of, looks like it might be on the borderline. But one hates to spend that much time on data, that little bit of data from so long ago. So the recommendations that we're kind of tossing around, I think when we write this up, it looks like a surface water monitoring plan has been something that's been requested for many, many years for the site in the 2007 review. It's part of the documents for the site. It looks like it is something that needs to be done. This is also very consistent with the increased amount of development along Murphy Creek. More and more of the property being used for residents. The 07 risk screening really shouldn't be referenced. It is very out of date. And there also needs to be a separation when this data is discussed between stormwater monitoring and surface water monitoring, because right now the data is all jumbled and there's not information in there that we can use to parse it out, less some, the meteorological records. And finally, simple flow measurements are needed to go with any data that's collected. And also, and I think this is an important point, as we look at a new groundwater monitoring plan, there is a relationship between groundwater and surface water that is completely expected here. And I think the shallow groundwater, these two things really can't be separate, particularly since the best surface water monitoring locations are always the ones that are associated with shallow groundwater monitoring. In addition to when these samples are taken, and one of the problems I've got when I do look at the data that has been collected, in addition to being small data sets and old, is it's not complete. It's not all the COCs, or it's not, and it doesn't include general water quality parameters. Right now, I show those connections, the similar concentrations in 1,4-dioxane, and they follow pretty well. But in reality, what you want to look at is it the same water type to really get a handle on that. So, and that's that for the presentation. Have any questions?
Yeah, Diedrich, this is David Berry. Is Murphy Creek a gaining or losing stream?
I don't think we have the information to determine that. I would assume, like a lot of creeks in that area, that it has reaches that some reaches are losing and some are gaining. I think, Earl, you were reviewing a nearby creek, one just to the east, that was probably running through some very similar geology. Was it generally losing or gaining through that area?
It was more gaining stream because of the contributions of recharge and urban runoff getting into the ground. It's the fluvial system right to the west of Murphy Creek, and there's a GIS study from 2007 that's kind of instructive for understanding things about Murphy Creek as an analog site. But you have the parts of the East Tollgate Creek system are gaining. The groundwater, the surface water system is gaining from groundwater.
Wow. The Murphy Creek.
Would someone explain the importance of gaining or losing and what that is, please?
Sure. Gaining is if you have the difference is whether or not it is groundwater is draining to the creek and moving down the creek, or whether the creek water in it is recharging back to the groundwater. It's really applicable here because if we have the groundwater moving to the creek and the shallow groundwater has issues, then they're in surface water as well. I think that the Murphy Creek system can be a little bit flashy. And one thing to keep in mind is it can actually be doing both depending on if there's a big storm and a lot of water running down, it can be recharging the aquifer. And then as the water level drops, it can start draining the aquifer. Which is not too atypical, but it's something that can be determined and will be important, and where knowing whether or not that's happening at these sample locations is really important in understanding the groundwater and surface water connections.
Thank you.
Any more questions? Oops.
Go ahead, Lisa.
No, I was just asking for more questions.
Again, it's Earl. Sorry to be the Mr. Question guy. I'm still learning a lot here. But Dietrich, I mean, as far as sample numbers, I mean, if you only have so many surface water points to sample, then that limits your data. I mean, you can't have, most statistical stuff likes at least a dozen or 15, so your statistics will run and be stable. But I'm not sure in risk assessment if the number of data points, and if it's surface water and you have a long suite of analytes that you analyze for, but you only have 4 or 5 places where you can sample, that unless you're doing a time series, the data is what it is. I mean, you can't make more surface water sites if they're not there.
Well, I don't think, and there is some question to exactly where these sites are, and some of the naming is a little bit of a challenge. It's one of the reasons I wanted to present a few of these things today, is hopefully I'll get some feedback to make sure that we're calling these sites the right thing. But I do think that there has been the suggestion, the 2007 review, as well as what we're seeing for the remedial objectives here, surface water is included. But it looks like in the actual planning and application, there's been the stormwater management and the surface water management have been conflicted. The result is we don't have enough data to really make a whole lot of decisions other than we have data that says we have 1,4-dioxane in the surface water along Murphy Creek throughout the entire area that's been studied up to the 2000, the later data. But again, we're also looking at 2 data sets only from the last 13 years. So yeah, it's a very data limited situation that I think really needs to be addressed if we're going to understand the shallow groundwater issues out there, and as well as the extent of the plume.
If there are no questions from the agencies or the responsible parties or the WSDs or whatever, does that mean they are in agreement with what has been presented?
Margie, this is Linda Kiefer. So I was being polite in letting people ask questions before I made a statement, but I will. So EPA will look at the information that Dietrich has presented in this. Since our conversation in June, I did have PWT go out and take pictures of all these sites. so that Dietrich, Earl, and anyone who wants to see them can see what these site locations look like. I did request information from the WSDs as to what the precipitation was during the 2016 sampling event. So I will send that on to Dietrich and Earl for them to look at. And I do want to note that EPA has done a risk assessment through Dr. Berry, and in collaboration with the state Tom Simmons toxicologist. So that information, once it's complete, will be available to the public and also for Dietrich and Earl to review. In that particular area, the Sand Creek wastewater reclamation facility does provide reclaimed water to the golf course for irrigation. That in itself complicates where the 1,4-dioxane may or may not come from. So that's a consideration. So what I would like to do is at the August CAG meeting, continue this conversation. EPA will have a presentation as to what our response is and how we can talk on this subject with each other. And I assume Dietrich and Earl, that's fine with you, right? Okay, thank you.
Thank you for that. And just clarification for me, the risk assessment that you're talking about, is that the old one or is that a new one?
It is brand spanking new. David Berry has been working on it for several months and working with Tom since April. So yes, that is current information with today's standard for what is 10 to the -6, what is 10 to the -4, and then different exposure pathways to potential pathways to different various people who use the golf course or live near the golf course.
So is that going to take into consideration the sump pumps or the homes in Murphy Creek that have a potential pathway through the sumps? Or are you simply using the older data of the golf course maintenance folks?
I'm going to ask Dr. Berry to address the sumps.
Yeah, we have no information that there are actual homes over the groundwater plume, which would then lead to potentially having water containing 1,4-dioxane in the sumps. But since there are no homes directly over the plume as we know it right now, there's no potential for 1,4-dioxane to be in that water that might show up in your sump pumps.
Well, that kind of presupposes that the plume is, like you said, where it's currently designated or where you folks currently believe it is. In case it's not where you think it is now and it's more extensive, then I mean, you'd be missing an opportunity to take those factors into consideration with the risk assessment.
Well, as I explained, we have no evidence that there are actual homes constructed over the plume as the plume has been defined.
Yeah, and what I've said is in case the definition of the plume is incorrect, then you really have no evidence that there are not homes directly over the plume. And there's also really no evidence that the water isn't seeping its way into these homes.
Well, if in fact the plume does extend under homes, then we would consider those options for exposure.
And how will you determine if the plume exists under the homes, since you're not really testing beyond where you believe it is today? I mean, we've kind of gone over this many, many times.
Well, with
That's a question.
the North End investigation report is what defines where the plume is based on the samples that we've taken starting back in 2000, I think it was 2006. So it's been monitored over the last decade or so, and that's how we've determined it.
Yeah, and I guess I'll just say, excuse me, one more thing, and then I won't beat the dead horse. And that is just that we being several members of the CAG have always taken issue with where you believe the plume is today. So it's just, we're going to keep going round and round. So I'm just going to mute myself and not talk about this particular issue any longer. But please note that I am in disagreement with this.
Will do.
Hi, this is
Richard, I got a question.
to Dr. Barry and Linda. 2 points. One is if you're gonna, when you present that risk assessment data, would you please present also the hydrogeologic data that proves the containment of the 1,4-dioxane plume, that and not just in dashed presumed lines, but something that shows us, say, the creeks in this area are ribbon, I guess I call them ribbon creeks. They are braided. They can, at one time, they may be in one place, but in times previously, they could have been somewhere else or adjacent to it, and have developed a sand pathway that could have gone into Murphy Creek housing. But you haven't, I don't think you have any evidence that shows that that you've looked for those ribbons. And so if you have that evidence, I think that would help everybody to feel better that it's not just a dashed line there, but you've really proved that there's nothing that could possibly be a pathway, and that you actually look for that, not just assumed it. And then the other is that what Dietrich just presented was basically, if I heard it right, there's a paucity of data on surface water and shallow groundwater. And you're going to make a risk assessment based on the data that you have. So if you don't have data, the risk assessment is as good as the data that you have. So would you please give us the data when you give us that presentation, so that we can really evaluate if your assessment is based on enough data.
Okay, I made notes of that for August.
Yeah.
Thank you.
Richard, I've got a comment. Can you hear me?
Yes.
Oh, good. So it's convenient to assume that there's no contamination farther than the few testing wells that you have done up on Mississippi. The groundwater, to my knowledge, flows northwest. The homes that we're talking about that pump groundwater continuously out of the sumps are pulling groundwater, and it seems to me, rather than to be the EPA should be proactive, not reactive, if something finds that, in fact, there is dioxane in some of those homes. And so I would just like to say, I don't understand why the EPA will not look farther at the request of the homeowners and CAG.
Sarah, can you talk about the groundwater and the sumps and?
Yeah, I'm trying to pull up my notes because this has come up before, and I believe we did look at this scenario to some degree. So I'm trying to figure out where I've noted that, but without wasting too much time. The sumps are likely pulling in irrigated water and water that's the shallow groundwater from in that area. I think we did look at the elevation of those sumps and those basements compared with the potentiometric surface, with the groundwater level associated with the Dawson and Denver formations, and there was a difference. So that indicates that the sumps are pulling out water that's infiltrated from the surface in that area. That's one thing. And then I guess the other thought that comes to mind, sort of, I'll refer back to Dave Barry, but in his assessment, he looked at actually drinking or consuming worst case scenario with the concentrations in the area. So, that would be the most conservative approach to looking at risk, potential risk of exposure compared to potential exposure through the sumps, I think. But I don't know, Dave, do you want to talk about that piece?
Well, I mean, when we looked at estimating and evaluating the risks associated with the shallow plume, we included all of the monitoring well data and the piezometer data that we have on the shallow groundwater. And we use that data then to calculate a mean and then a 95th percent upper confidence level on that mean. And that's kind of the concentration that we would use in a risk assessment to evaluate a reasonably maximally exposed individual. And we took those data, developed what we would call an exposure point concentration, and then we assume that a resident would poke a hole somewhere out there and use that water for a potable source. So we then included ingestion of groundwater for children and adults. We also considered dermal exposure to adults and children, and inhalation during bathing. And we have made the assumption that the resident that would be out there would be a combination of a child from 0 to 6 years and then an adult from 6 to 20 years for a total exposure period of 26 years. And that's pretty much a standard risk assessment protocol used by EPA to assess risks from groundwater. And when we did that, the risk for using the groundwater as a potential potable source out there was in the range of 6 times 10 to the minus 6. So it's within the risk management range that EPA uses, which is 1 in a million, which is 1 times 10 to the minus 6, to 1 in 10,000, which is 1 in 10 to the minus 4th. And all that will be, put in that little risk assessment that we've conducted.
So I have another question, Dr. Berry. What is the shallowest
Richard, can you
groundwater?
speak up a bit?
What is the shallowest depth for groundwater? It's 30 feet, 20 feet?
Sarah, I think it's somewhere in the neighborhood of 25 feet. Isn't that correct, Sarah?
That's the right ballpark. I'm actually that one picture that was part of the molybdenum discussion, I think had the groundwater surface on it. So I was looking to bring that up again.
Richard, this is Tim Shanker. It depends on where you are. If you're right down by the stream, the depth of groundwater is shallow. But if you're closer to the homes that we're talking about, where you're quite a ways away from the creek, you're 20, 30 feet above groundwater table.
Yeah.
So the reason for my question is the sewer water trenches, when they're dug, are 17 to 20 feet deep before they bed them, which could be a pathway for the groundwater. When they dig a basement, usually they're down about 15 to 17 feet before they finish up the basement. So that was why I questioned the depth of the groundwater.
Dr. Berry, this is Tom, just for a second. I don't think that you're aware that one of the CAG members had her sump pump in a basement running almost constantly for years. And so that would mean that the groundwater had gotten up to her basement, and therefore, if there was 1,4-dioxane in it, it would be able to aerosolize and become, and be a contaminant within the air. And if a lot of work was done in that basement, or if that basement was closed off, the concentrations could get pretty high, just like radon. And so if you've done your calculations, could you do a similar calculation and as to what might happen if there's 1,4-dioxane in sump water, and present that? If you did, and it showed that it was less than 10 to the minus 6 exposure, less than 10 to the minus 6 chance of cancer with that kind of aerosolization, at a reasonable concentration of 1,4-dioxane in the water, which you can maybe give some variables, that might put our minds to rest. At least it might help.
Tom, let's do this. Let's talk a little bit about the physical chemical properties of 1,4-dioxane. 1,4-dioxane is what we classify as a semi-volatile compound, and as such, it has some physical chemical properties, one of which is called the Henry's constant. And the Henry's constant is a constant that kind of assesses whether or not the compound wants to stay in the media that it's in or go to a different media. And the Henry's constant for 1,4-dioxane is about 4.8 times 10 to the minus 6 atmospheres per meter cubed, which means it's not very volatile. And in order for you to get significant volatilization of 1,4-dioxane from the groundwater, you're going to need concentrations that are in the range of around 2 milligrams per liter. And we don't have those kinds of concentrations out there.
May I ask a question? Um, Dr. Berry, is that the only chemical that we need to be concerned about when we're addressing the possibility that some of these contaminants are being sump pumped into the homes? I mean, I appreciate your description of 1,4-dioxane and its volatility, but aren't there other chemicals in the water that are traveling in this this groundwater that the sump pumps are going to be pulling up?
Yeah, there are other chemicals, but I don't think there are any other volatile chemicals that are out there that are of a significant concentration. Your shallow groundwater is going to have, reasonably high levels of nitrates. It may have some phosphates in it, and those are not volatile. But the only chemical that we are concerned with in the north boundary plume right now is the 1,4-dioxane.
Yes,
Okay.
and to clarify the answer, the water that may be pumped by the sumps may have a suite of other chemicals, but the ones that you might think of could be contributed by land application of fertilizers, things like that, associated with Lowry, and the monitoring program north of the site. 1,4-dioxane is the only site-related contaminant
Chemical.
in the groundwater.
Thank you.
Sonia has a question. Sonia?
Yes, I have a question for Dr. Berry. So I would like some clarification. I'm a little confused. You mentioned that the assumption was that was based on the well sampling sites and the data produced from those. But you also mentioned an assumption of direct use of water, as if someone were siphoning it off from the plume. So I'm wondering which measure you're using for the calculations you're going to produce. And then part two, if there were homes directly over the plume, would that change any of those numbers you're using and plugging in to make those calculations?
I'm not quite sure I understood the first question that you asked. The second question that you asked is it kind of depends on where that well might be placed. Because concentrations in the wells and piezometers out there range from non-detect values to I think somewhere around 10 micrograms per liter. And even if you put a well in the area where 10 micrograms per liter would be, you would be looking at, if you assume that you use that for a potable source and use the same assumptions that we used for the 95th UCL value for the plume, the risk then would be in the 10 to the minus 5 range. It would be somewhere around 2 times 10 to the minus 5 range.
Okay, so then as I thank you for clarification. So as I understand it then, the values you're using are based on a mean derived from a range of wells that you're looking at that are in the higher range that would have any impact. And that's the value you're using. Is that right?
The value that we're using is we take all of the data for all the monitoring wells in that plume, and we calculate an average value for those wells. And then what we do is we calculate what we call a 95th percent confidence interval on the mean value, which is higher than the mean value. And we use that value then to evaluate what the exposure, or that becomes the exposure point concentration that we use to evaluate risk for someone potentially using that aquifer as a potable source.
I have another slight clarification. So Dr. Berry is describing the work that he's doing in combination with the state right now. There was a response to comments to the CAG where it did include cherry picking the highest levels in the area and saying, okay, worst case scenario, let's look at exposure risk if this concentration was what somebody was consuming or coming into contact with. So Sonia, you might be thinking of that explanation from that earlier letter too.
So that's exactly what I wanted to ask about, was using the worst case scenario value to have that information. And so I wanted to know if that would be included in this current risk assessment that Dr. Berry is doing.
No, that would not, because what traditional risk assessment does is it uses two exposure concentrations to estimate risk. And we calculate what we call an average value and a reasonably maximally exposed value. And the reasonably maximally exposed value is based on the 95th confidence interval value on the mean. And an average exposure would be using the mean concentration.
And that's why we did include that highest concentration in that response to comments letter, because it's outside the process, but it still is informative and I think speaks to some community concerns.
Okay, can that that segment be attached to the risk assessment as a reference or a note so that people's memories can be refreshed about that value?
We could make that letter available again. That'd be helpful.
Yeah, okay, then if you won't attach it to the report for reference and review, perhaps you could send it out to us again after this meeting just to refresh our memories.
Going back to the idea of inhalation being an exposure pathway that's a concern, one of the CAG members say that in the chat, the EPA classifies 1,4-dioxane as a group B2 probable human carcinogen by all routes of exposure. Inhalation is the most common route of exposure. Can you respond to that, David?
I'm not sure that I fully understand the question that was asked, but 1,4-dioxane was used primarily as a stabilizer for 111 TCA, and it was used fairly extensively for that chlorinated solvent. But 1,4-dioxane does show up in a lot of commercial products at very low levels. It's used in cosmetics. Sometimes you find low levels of it in certain surfactants. The toxicity value that IRIS program developed for 1,4-dioxane was based on a oral exposure of 1,4-dioxane in water. So the actual toxicity value for 1,4-dioxane is based on an oral exposure, not an inhalation exposure. And because of the Henry's constant of 1,4-dioxane, it's not very volatile. It's not like TCE or chloroform or one of the chlorinated solvents that have Henry's constants in the neighborhood of around 2.1 to 1.1. So it's not nearly as volatile as chlorinated solvents.
David, I think they might be asking a slightly different question than you answered. While yes, the Henry's law constant is what controls the ability for 1,4-dioxane to volatilize from water, there is a high vapor pressure that allows 1,4-dioxane in a pure form or on dry surfaces to easily volatilize. And that's a large part of what in an industrial and worker safety scenario is a concern from an inhalation standpoint. So I think that you're very focused on the groundwater, as you should be, but from the standpoint of understanding the chemical and how it moves through the environment, I think it's important to recognize that the vapor pressure of 1,4-dioxane alone, not when it's mixed in water, is the controlling factor on it becoming volatile from other dry surfaces or from pure 1,4-dioxane.
Yep.
Dr. Berry, this is Tom again. I think that I'm going to try to paraphrase something that I'm hearing, is that I understand the statistics are not going to use the worst case scenario, but you're dealing with people that are living by a stream or a plume of 1,4-dioxane that at this point is decreasing in concentration. But to put people's minds at ease, if you give a worst case scenario that could be possibly right now and not 10 years ago when the 1,4-dioxane level was maybe 45 instead of 10, but at least now, and give that to us as the CAG and say, okay, if a house was put right on top of that well, the 1,4-dioxane was 10, and all of the worst case scenario for that house would be such and such, and still it's going to be below. It's going to be in the 10 to the -4 to 10 -6 category for cancer risk, and really explain that. Don't just say 10 to the -6. Say 1 million to what? Anyway, give the actual percentage so that in layman's terms we can understand it. I think that we'd be feeling better about what our safety is, and that would kind of mitigate the fact that we don't think that there's been enough study to tell whether or not the 1,4-dioxane is coming in under the house of somebody's house, because there may be a ribbon there. But if you're saying, okay, say there's a ribbon there, and say that it's 10 micrograms per liter in the water, this is the worst it could be for you guys. I think that might help. And I know that's not the statistical method, but you apply the statistical methods to that, saying, you're not going to put it in the report, but if it's not going to be a risk for us at that level, then I think people will be a lot happier.
Well, Tom, if I remember correctly, and I don't have my spreadsheet open, but if I remember correctly, the 95th confidence interval concentration that we used for the plume was 2.9 micrograms per liter. And at that value, I think the risk turned out to be, 6 times 10 to the -6th. If the maximum value out there is 10 micrograms per liter, that value would calculate out to, I think, somewhere around 2 times 10 to the -5 in risk. We're obligated as the EPA to stay within certain rules or regulations of our risk assessment. So we are obligated to use the average concentration in the plume for the average exposure value, and then the 95th percent confidence level limit on the mean to use to calculate what we would call the reasonably maximally exposed individual. So those are the two values that I have to deal with as far as what gets included in the risk assessment. But there's no problem with us telling you, calculating the risk on the Cmax and what that would equate to. But we can't put it in the risk assessment.
Cmax is maximum concentration.
Thank you. So in the risk assessment, here's another question from a CAG member. In the risk assessment, did you include air impacts on babies and children breathing the air in? Before 2013, the IRIS did not have, IRIS did not have a number for dioxane. Many new studies are emerging that indicate that dioxane can volatilize.
We considered the volatilization of 1,4-dioxane during bathing only. We have what we call a shower model that models volatilization of compounds out of hot water into the air and in a closed shower. And that is the way that we assessed the inhalation exposure of 1,4-dioxane.
Oh, you have another. Go ahead.
Yeah, I have another question. So in follow-up to Tom's comment regarding use of a worst-case scenario as opposed to the more abstracted numbers of the 95th confidence interval, and your explanation that the EPA is constrained by certain guidelines from providing that kind of analysis, I wanted to know if the CDPHE is similarly constrained, or perhaps the CDPHE could provide that kind of analysis for us.
It's not a question necessarily of whether EPA or CDPHE could provide you with the numbers. It's just that there are certain requirements within the risk assessment paradigm that we have to follow when we conduct a risk assessment. And as I said, I don't have a problem with giving you all a value for what the risk might be for the maximum value detected in a monitoring well out there. I just don't have the ability to put that in the risk assessment. I could put that in, I suppose, in the risk assessment if I wrote an uncertainty section, and you would find it in the uncertainty section. So I could do that.
That would be helpful.
This is Diane. I just wanted to add just a little bit of general perspective too. So when we're talking about the difference between these values and how it calculates the risk, a lot of the time the difference between the 95 UCL that protocol tells Dr. Berry to use and the maximum concentration out there. So, let's say, for example, these are totally just generic numbers, that the 95 UCL was 10 micrograms per liter, and it calculated out to cause a risk of 1 × 10⁻⁶. So that means that if the concentration was 100 micrograms per liter, it would correspond to a risk of 1 × 10⁻⁵. So, for each times 10, the risk would go up from 10⁻⁶ to 10⁻⁵ to 10⁻⁴ and up. So, if the 95 UCL value is 10, the maximum would have to be 100 for it to really make a substantial change in the calculation risk. So that's how much the calculation would change based on 10 times the concentration. in groundwater. So I don't know if that provides a little bit of perspective. So if we're talking about the 95 UCL is 10 and the maximum is 15, it really wouldn't change the risk calculation that substantially.
Yeah. And to add to this, just for 1,4-dioxane, the 1 times 10 to the minus 6th risk value for 1,4-dioxane is 0.46 micrograms per liter.
And that's
so,
the scenario that if that was somebody's daily drinking water source, is that?
Yes, yeah. And there is, so then if you look at increments of 10, 4.6 micrograms per liter of 1,4-dioxane would equate to a 1 times 10 to the minus 5 risk level. And 46 micrograms per liter would then equate to a 1 times 10 to the minus 4 risk level.
And does everyone understand the 1 times 10 to the minus 6 and minus 5? David, you could spell those out in the 1 in a million.
Well, yeah, well, 1 times 10 to the minus 6 is basically a 1 in a million risk value. And a 1 times 10 to the minus 4 is a 1 in 10,000 value. And those are probabilities.
Okay, so this is Lisa. I just want to do a quick time check. We are, while we have naturally migrated to Dave's topic, I don't know if he wants to take 10 minutes or so to quickly walk through his presentation, or if folks would like to continue this more specific discussion about the basements and
I'm perfectly willing to entertain, questions, since supposedly we only got about another 12 minutes or so, and I could do the risk presentation then another time. So if people have additional questions, I'd be happy to try and answer your questions.
What I would like to have happen, just for myself personally, is to be able to direct questions to Dr. Berry and have them answered directly, and maybe not under this forum, because I think we do run out of time. But to ask specific questions and to get specific answers and through another medium. And to also register for the record what our concerns are in writing. Janine, I'm not sure how that works with regard to keeping a record of what has been said and what the questions have been. Are notes being made other than just the summary of the minutes?
No. No other
Okay,
notes
so
are being.
if we want something on the record, we have to enter it to the record directly to that person or directly to the group. How does that work?
Well, as a group, you always have the option of writing a communication in the form of a memo or a letter or some other way,
Okay.
and address it to whoever you want to
Okay.
lodge it with. It could go just to EPA, it can go to both agencies, whoever you want
Okay.
it to go to.
And then for Dr. Berry, then directing questions to Dr. Berry, we can do that a one-on-one, but I'm just saying that there's stuff that isn't answered yet or that we're wondering about, and so the conversation would need to continue. I don't want to put it off for another month to find out what would happen, a month from now. So we can do that on our own, I would assume.
Well, you still have time to ask me questions if you want to.
Well, I need more time to formulate my question. So I will probably direct that to you on another forum. So thank you.
Because I don't bite.
I'm sure you don't.
Yeah, he does. No. The other thing you have the option of doing is you're in the meeting now and you're thinking through this process now. Remember that this is being recorded and it'll be posted to the CAG YouTube channel, and you can always go back to this portion of the meeting and listen to it again. That might help you formulate what it is that you want to know.
Okay, I appreciate that, Janine. Thank you.
Sure enough.
And if you have questions for EPA, Dr. Berry, you can send them straight to Lisa McLean Vanderpool, and she will make sure it gets to the right person and it gets answered. We still are, finalizing the risk assessment with the state, with Dr. Berry and Tom Simmons. So once that's complete, we will release that, and then you might have some questions based on that or want some explanation on things, and we can certainly talk about that at the next CAG meeting. It is just not final at this point.
Okay. Any more questions for the meeting? So we are probably too short for Dr. Berry to present or get into any of his presentation now. So we can always put that for the discussion about the risk assessment itself, and then he can go over some of these more explanatory, explanations of the risk assessment process that he was going to talk about tonight at the same time, so that it'll be a more thorough kind of discussion. Does anyone have anything else they'd like to?
Yes, actually, Tom has a question for Steve Richtel.
Hi, this is Tom. Steve, you there? Is Steve Richtel still here?
Yeah, I'm here. Sorry. I had it muted.
Okay, right. When I gave you that that well, that C-702Q2
Yes.
with a molybdenum level of 45.8 in 1995, I've noticed that there is a monitoring well close to it, the C-702Q1. And I would like to ask that you still measure C-702Q2, not Q1, for the following reason. If you look at MW113 with molybdenum level at a point where it was 32,000, I know that it was higher, or may have been higher or lower later, but it's right adjacent to B326.
Yes, that's correct.
Both of them are both are in the Weather Dawson. Both have screening levels to that are approximately the same.
That's right.
Yet they're only maybe 40. I was thinking 40 to 50 feet apart, unless I'm wrong, maybe 100 feet apart. Those levels between the two wells at the same date or essentially a similar date of measuring was 32,000 versus 4.5. And I think that shows that in our geologic area, at a very short distance apart, we can really see a huge concentration of something. And then if you move just a few feet away, 140 feet, 50 feet, 100 feet away, then you may miss it completely. So I would ask that you don't just take the information from the monitoring well Q1. I'd ask that you go to the well where previously molybdenum was found and test that one.
Which is Q2, correct?
Right.
Yeah.
Okay, thank you.
I got a question for Steve.
Speak up,
Steve,
Richard.
Okay, the area where you're drawing the molybdenum groundwater contamination from, is my understanding that that area lies over the ground fault. Could you be pulling up from that ground fault?
We have vertical wells beneath this area, and the water levels in those deeper wells are lower than the water levels in the shallower wells, meaning the potential for flow is downward, not upward.
But when you're extracting, you're pulling up.
Correct. You're pulling in lots of different directions.
Right, but basically you're pulling stuff up too. So I'm just wondering if that is helping find.
Well, all I can tell you is we sampled the deeper wells and they're clean. And there's a lot of literature out there about whether that fault exists and what its impacts are, et cetera. And I would refer you to those. I think most reviewers have concluded that even if there is a fault, it has no significant impact on contaminant transport.
Gotcha.
Okay, folks, I think that brings our meeting mostly to an end. We are, always open to hearing your interests and topics for upcoming meetings. And you can always communicate anytime with Janine and I on any and all matters concerning these meetings, the topics, the questions, all of it. So hopefully you know that that door is open. Everybody okay? Anything else? Janine?
Looks like we're done in the chat room also.
Okay, good.
So it looks good.
Linda or Dustin, any last minute?
No, thank you everyone, and stay safe.
Yeah. Everyone stay safe, and thanks to the presenters tonight for all the information. Actually, Dietrich, can you send me yours so we can send it out?
Yeah, I provided a copy to Bonnie, and they'll be providing it, I'm sure, relatively soon.
Okay. All right. Thanks all. We'll be in touch soon.
Thank you.
Thanks.
Bye.
Thanks. Bye.
Thank you.
Thank
Bye.
you.
Thank you. Bye.
Mr. Baker, nice to see you.
Hi, Janine. It's good to see you too.
How have you been?
I'm pretty good. We're all healthy here, so.
Oh, good.
Yeah.
Yeah.
Thanks for asking. Yeah,
You bet.
busy. I was a little late arriving, but I got here about 4:45.
Right.
So.
Yeah, I saw I had to allow you in. I'm gonna bring you in from the waiting room, they call it. So.
Yeah.
So you have a good night. Be safe.
Thanks, you too.
Thank you. Bye-bye.
Bye-bye.